Hi everyone, welcome to the Wolfram Mathematica series. So today we will see the how to draw the graph of the following sequence of the function of the given interval, and then we will also discuss their pointwise convergence respectively. So I have taken the example of the sixth function, that is x to the power n in the interval 0 to 1, and then with the same function I have changed the interval, that is -1 to 1. Similarly, the next function I have taken x by n on the interval r, that is real number. Then the second function is x square plus nx upon n on r, and in the fifth and sixth question you can see the question is almost similar, but the value of the angle change. In the sixth question I have nx, and in the fifth question I have angle, that is nx plus n, and the interval is same, that is r. So before to start this video, start this lecture, as you know that we have already discussed about the pointwise convergence of the sequence of the functions in the real analysis. And if you don't know about this, then you can search the video, that is pointwise convergence by Akash Vesh, and then you will get the video. And I will give you the brief introduction about the pointwise convergence. That what do you mean by the pointwise convergence? Is that when the function which lies between the interval, as you can say, take the example of x to the power n. Now put the value of x between the interval 0 to 1. You will get, suppose the sequence 1 by 2, I have taken x is equals to 1 by 2, then the sequence becomes the 1 by 2 to the power n. If you take the value of x by 1 by 4, then you will get the function, that is 1 by 4 to the power n. So in this way you will get your sequence. So if the every sequence, if the every function lying between the given interval converges to one point, then it is said to be the pointwise convergence. So in the simple language you can understand about this, and if you want the more understanding, then you can search the video. And if the pointwise convergence is continuous on the every point, if the pointwise convergence is continuous on every point, in what does it mean? That if in the given interval you get the same value of the limit of the function, okay, of every function, then it means it is said to be the uniform convergence. So pointwise convergence can be the uniform convergence if you get the uniform value of the limit on each and every function. So in this way we will proceed for the pointwise convergence. So let's start the video with the first example that I have taken, that is x to the power n is my function in the interval 0 to 1. So first we will find the limit of x to the power n by giving the command limit. Then in the square bracket write the x to the power n. How you can write all these things? You go to the palette section. In the palette section, click on the basic math assistant, and then you will get the basic math assistant section to be like this. From here you can see the cursor, that you will get the arrow sign, and if you want to write the x to the power n, then you can see the arrow. From here you can write this way, so you can search in this, you can write each and everything. Okay, so define the function x to the power n. Now n tends to infinity, and in the assumption you have to put the value of x. Now first I am finding the limit of x to the power n, where my x lies between 0 greater than equal to less than 1. Why less than 1? Because you know, when you put the value of 1, x to be 1, and 1 to the power n, when n tends to infinity, then you know the limit is 1. But if the value of x is less than 1, that is 0.99, okay, 0.99 10 to the power n, 0.9 to the power n, where n tends to infinity, then you can see the function will goes to the limit 0. So that's why I have taken the x to be 0 greater than equals to x and less than 1. Then you will get the limit 0. Same, find the limit of x to the power n where n tends to infinity. Now in the assumption you have to take the x equals to 1. Now my function will become 1 to the power n. So 1 to the power n tends to what? The limit will be 1. So always remember, when you put the value of variable, then you have to use the double equals to sign. So do not use the single equals to sign, then it will not take your value. So give the double equals to sign. Now from this first and second output, you can see, to get the output you have to press the shift plus enter key. Press both key, shift plus enter, then you will get your result. Now press the alt plus 7 key for the text. So for the text I can see the conclusion. What I get, that on the interval 0 to 1, the function x to the power n is lying between, when x lies between 0 and 1, you can see that you are getting the limit 0. When x is equals to 1, then you are getting the limit 1. So if you get the same limit, that in place of 0, if you get the same limit, that is 1, then what you will say, that it will be the that it will become the uniform convergence. But now I'm getting the different values, okay, that is 0 and 1, then what does it mean? That it is not a uniform convergence, so it is a pointwise convergence. So I can see from here that in between 0 and 1, for every value of x I am getting the limit, that is 0 and 1. Now to draw the graph, first define the function, that is f n subscript and x subscript. Why I am using the subscript sign? Because I will put or change the values of x and n according to the graph. To draw the graph I have to put these values, so that's why I have taken the n subscript and x subscript, and then write the function x to the power n. Then press shift plus enter key, you will get the result, that is x to the power n. Then if you want to find the different function, then put the values of x and n simultaneously and you will get the result. Suppose I have taken the value of n is 1, then x, then what you will get? You will get the result x. Similarly, if you want to find the x square, then put the value of n to be 2 and keep the x as it is. Or if you want to change the value of x, then put the values of x between 0 and 1. So to draw the graph, what you have to do, you have to give the plot command. Now give the plot command. In the plot command, what I am doing, that I am changing the values of n and keep the variable x as it is. So you can see from here that I am writing the f1x, f2x, f3x. What is f2x? F2x is the x square, that is the value of n is 2 and x is as it is. F3x is what? That is x cube. F4x is what? Uh, x to the power 4. Similarly, in this way I have taken up to the f10 x to the power 10 and up to the f x to the power 30. You can take up to the any expression. Now define the x varies from, the x varies from 0 to 1. So give the command, that is x varies from 0 to 1, and now the plot legend, give the command the plot legend. For the plot legend you will write the expression. What you will get? You will get the graph of the different line, then you will get the name of the different line, that what line represent the which function. Okay, then press the shift plus enter key, you will get your graph to be like this. So from the graph you can see that the every point when the values of x is less than 0, then you can see that it is lying between, that the limit would be 0, so it is tending towards 0. And when the value of x is 1, then you will get it is converging on the point 1. So if you get if you want to put the value of n to be 100, then you can also give the command n f bracket square, within a square bracket write the 100 comma x, and then you will get your graph. And you can see with the plot legend command, then you can see in the right hand side that these different lines give the which function. So in this way you can draw the graph. And if you don't want to give this too much expression, and if you want to write down the a less expression, then give the plot command, and then in the square bracket give the table command. In the table command, what will happen, then if when your function is x to the power n, you are varying your function, that is n and x. So in the table command, yeah, this will take the value automatically, that my n is varying from 1 to 10 and value of x is varying from 0 to 1. So when you give the shift plus enter command, then you will also get the same result from the above graph, that you can see from here that it is converging on 1 and 0. So when the value of x is less than 1, you can see it is converging in the 0, and when the value of x is 1, then you can see it is converging on 1. So in this way you can see the graph. You can also change the value of n, that if I change the value of n, that is 1 to 20, and when you press the shift plus enter key, then you can see the graph does not change. Then it is again the same, that it is converging on 0 and 1, but is not exceeding the 1 and 0. But you remember that in the question it is given to you that your value of x should be lie between 0 and 1. So I hope you have understood the first question very well. Now if you get the any problem, you can ask me in the doubt in the comment section. Okay, so there I will solve your query. Now come to the second question. In the second question you can see you have to find the limit x to the power n. Now your interval changes, that is -1 to 1. So as you already know that when the value of x is -1, so -1 to the power n, when n tends to infinity, you will get that the limit is not same, because when the value of n is positive, even, then you will get the 1 as the limit, and when the value of n is odd, then you will get the limit to be -1. So on the -1 you can see the value of 1 is not converging on the 1 point. So what we will do, first we will find the limit of a function by giving the limit command x to the power n, where n tends to infinity. In the assumption you will write that the x value varies from -1 to 1. So when the x varies from -1 to 1, in that you know the limit would of the function would be, limit of the function would be 0. So limit of the function is 0, you can see from here. And when the limit when I am finding the limit of x to the power n, where n tends to infinity, assumption, now on the value of x equals to 1. So when the value of x equals to 1, you know the limit of the function would be 1. So the limit of the function, what you will get, you will get the 1. So in this way you will see your answer. Press the shift plus enter key and you will get your answer. But on the x to the power n, n tends to infinity, in the assumption when you get put the value of x, use the double equals to sign on both the equation, equals to the -1. When x value is -1, then you can see you will not get your result properly, that the limit is not changed, it is changed accordingly depending on the value of n. When the value of n is positive or negative is different, so it is not the pointwise convergent on the -1. So in the conclusion you can see the pointwise limit of the function, that is x to the power n, on the interval -1 to 1. You can see when the value of x is what, -1 to 1, you will get the limit 0, and when the value of x is equals to 1, then you will get the limit 1. So in this way we can see our conclusion. And so x to the power n is a pointwise convergent on open interval, -1 to 1 close interval. So open interval, why I put the open interval sign on the left hand side of the -1, because on the -1 it is not convergent. Okay, it is not a pointwise convergent, so that's why I have write this form. So now to give the graph command, give the plot command, and then again vary the value of n, that is 1 to the power x. Before that you have to define the function, that is f n subscript x subscript is equals to x to the power n. But in the above question I have already defined the function, that's why I am not written the uh, function again. So give the plot command and then write the function, that is f1x, f2x, f3x, and up to the f10 comma x, that is x to the power 10. And now your value of x is lying between -1 to 1. Then give the plot legend command. In the plot legend command give the expression. With the expression you will get the each color line represent the which function, so you will see in the graph. So you will get your graph to be like this. So in this way you can see in your graph that value of the function is convergent on the 0 point. You can see on the origin that it is converging, and on the 1 it is also converging. But when x to the power -1, you can see it is diverging. it is going upward and downward. So on the -1 you can see when it is going towards the -1 it is not convergent, but when it is going towards the 0 to 1 then it is converging, that is on 0 and 1. So in this way we can see the graph of the function, and you can also give the manipulate command. Then how to give the manipulate command? So if you don't want to draw the above graph, and if you want to draw the table graph, then what you will do, that you give the manipulate command. In the manipulate command, give the function to draw the graph, we will use the plot command. So manipulate command is to vary the function, and plot command is to draw the function. And in the plot command we will define our sequence. So we can see when we change the value of x to the power n, that is first function is x to the power n. So let us take the example n to be 1. So next function would be what? N to the x to the power 2. So x to the power 2 can be written as x n plus 1, then x n plus 2. So you can take up to the 3 sequence that change the value of n, that is n plus 1, n plus 2, n plus 3. Then you will get your sequence in this way. Now you know that value of x is divergent on the -1, so I have taken the function that is I am varying the x, that is -0.5 to 1. In the plot range, you what you are defining, that you are defining your axis, that is x axis and y axis. So I am defining my x axis and y axis of the function to be the -1 to 1. So whenever the graph comes in front of me, then we can see the graph will lie between the -1 to 1. Y axis is also between the -1 to 1, and x axis is also between -1 and 1. Axis origin, for the axis origin what you will get, put the 0 0. It means we are taking the center to be the 0 0, and now define the value of n, that is 1 to 100. So I have changed the value of n, that is 1 to 100. So in this way you can also give the shortest command, that is the less command. You can see now in with the graph you can see when you vary your n, you can see the how the graph changes. So when you moving the graph from the right side, left to right side, then you are coming towards the x to the power 100, and when you are going on the left side, then it means you are going towards the x to the power 1. So what is the meaning of the manipulate command? That you will get this type of graph where you can vary your value, that now I am varying my value of n, that is from 1 to 100. So in this way you will get your graph to be like this, and from this graph you can also see that it is also converging on 0 and 1, but not exceeding that. Okay, so if you give the again, that is x to the power n plus 4. So I have written x to the power n plus 3. So next would be this. So give the shift plus enter key, then you will also get the result. Now in the graph you can see the red color line is also coming in the graph, which showing the x cube graph, and it is also converging on 1 and 0. Okay, so you can see the graph of the function. So change the value of n and you will get the graph. So I hope you understood the second question, and if you get the any problem, then you can ask me in the comment section, and don't forget to like, subscribe and share my. Okay, so come to the third question, that is the find the pointwise limit of the function x by n. Now my function is what? X by n on the interval r. So first finding the limit, that is limit x by n, where we are varying the n tends to infinity. In the assumption on the real line, I can see the value of x will vary from minus infinity to infinity. So infinity sign you will get in the palette section. Okay, so infinity sign you will get in the palette section. Go to the palette and then basic math assistant, there you will get the infinity sign. Okay, so on the real we find the limit on the minus infinity to infinity. When you press the shift plus enter key, then you will get the answer to be 0. So when my function x by n varies from minus infinity to infinity, the limit would be 0. So from here what I can conclude that the pointwise limit of the function x by n on the R is f of x is equals to 0. So your limit would be what? Your limit would be 0. Now to draw the graph, we will define the function that is f and x n subscript and x subscript, because we will vary our value of n and x. So when you will vary your value of n and x, mm, yes, vary your n and x, you will get the graph. So this is my function. You will get your function after pressing the shift plus enter key. For the graph, give the plot command and vary the value of n. So when you vary the value of n, that is f1x, f2x, f2x means what? X upon 2. F3x means what? That is x upon 3. So you are varying the value of n and your value of x on the real number. You can take any value that is minus infinity to infinity between. So I have taken my function from minus 100 to 100. So I am varying my x from minus 100 to 100, and then give the plot legend command. In the plot legend, write the expression in the double subscript sign. Okay, in the double equals to sign. So you can see the graph from here, that you will get the graph to be like this. So in the graph you can see the all the points is converging on the center. So on the origin, you can say why it is origin, because we can see the limit of the function is 0. So limit of the function is 0 means the every sequence of the function that is x by n is converging on the origin. And you can see on the left and right side of the origin it cannot be converged because it is diverging in nature. Now if you want to give the manipulate command, then give the manipulate command to be like this. To manipulate your sequence, what you give the manipulate. In the manipulate we will draw the graph, that is plot command. And in the plot command I will change the value of x n, that is n plus 1 n plus 2, and x I am varying my x from minus 10 to 10, and the plot range is also minus 10 to 10. I have taken the plot range, means the graph, the value of the graph of y-axis, you can say, will vary from minus 10 to 10, and the value of n we will vary. So I will keep it outside the square bracket of the plot, that is give the value of n. So I am varying my value of n to be 1 to 100. So when you change the value of n, that is you are going toward the 100, then you can see the graph of the line in the graph, that it will converges to 0 or it will lie on the y-axis. So when you moving towards the 1, then you can see the graph will vary to be like this, and it will be converging on the 0. So the limit of the function would be 0. So in this way we proceed for the third part. Now come to the fourth part. Now your function is what? X square plus nx upon n on the R. So that's my function, that is give the limit, and x square plus nx upon n, where n tends to infinity. In the assumption we will write the value of x is lying between minus infinity to infinity. So when the value of x lies between the minus infinity to infinity, then you can see the value of the graph, the value of the limit would be 0. So press the shift plus enter key, you will get your result to be the 0. So in the conclusion, you can see the pointwise limit of the function x square plus nx upon n on the R is what? F of x is equals to 0. So that means that you will get the pointwise limit of the function to be 0. So it means it will converge on 0 at every sequence or at every point. Okay, so now define the function for the graph, that is f n subscript x subscript. Now you understood that why we are using the subscript sign, that x square plus nx upon n. So now change the value of n. Now in the plot command to draw the graph, change the value of n, that is f1x, f2x, f3x, f4x, f5x up to the f10x I have taken. So when you put the value of n, then you will get the different sequence, and we will vary our x from minus 10 to 10. Then give the plot legend command, that is expression, and you will see your graph to be like this. So in the graph you can also see that it is converging on the origin, that is 0, and on the left and right side you will get the diverging function. So you can see the graph of the function to be like this, and it will converge on the origin. So I hope you understand, and with the plot legend command I get the expression of these line, that is the red color line shows the x to the power, that is f4x, and blue line shows the f7x. So in this way you can see with the help of the plot legend command. Now to manipulate the graph, just take the function your as it is and give the manipulate command and then plot command, because in the manipulate we are drawing the graph. So give the x square plus nx upon n, then change the value of n, that is n plus 1 upon x square plus n plus 1 plus x, then x square upon n plus 2 plus x. So I have taken the three sequence of the function, and the x is varying from minus 10 to 10 I have taken, and the plot range I also taken the same, that is minus 10 to 10. With the plot range, why I am using the plot range command? In the plot range you will get the value of the y-axis. Okay, that you are varying your y-axis, that is minus 10 to 10, because you have already defined the x-axis, that is minus 10 to 10. Okay, so if you are varying the value of x minus 10 to 10, it is automatically means that you are getting the value of x-axis, that is minus 10 to 10. Now we will vary our n, so keep the n outside the plot bracket, that you will vary your n from 1 to 100. So you will get your graph to be like this in the manipulate command. And in the manipulate, when you vary from left to the right side, you can see the graph will change and it will converge to 0. You can see from the graph that it is converging on 0. It becomes the straight line almost. And the when you moving towards the left hand side, you can see it is diverged in the 3, because we have taken the 3 sequence, and it will converge on the 0 again. So whenever I am varying the value of n, so the graph is converging at the one point, that is the 0. So in this way we will draw the graph of the function, that is x square plus nx upon n. Then come to the fifth part, that is the pointwise limit of the function sine nx plus n. Now remember the angle is nx plus n, so don't write nx and plus n is separate, so it is whole as the angle, that is the on r. So first we will find the limit of the function, that is the limit sine nx plus n in the numerator within a square bracket and then whole divided by n. Now I am varying my n from tends to infinity, and my x is varying from minus infinity to plus infinity. So whenever my x is varying from minus infinity to infinity, I can see the value of the limit would be what? The value of the limit, you will get the 0. The value of the limit would be 0. So in the conclusion, you can see the pointwise limit of the function fx is what? Sine nx upon n. This is your function. You will get the result 0, or you will get the limit 0. So that's why the conclusion would be fx is equals to 0. That is the pointwise limit of the function. Now to draw the graph, we will define the function, that is f n subscript x subscript, that is sine nx plus n upon n. So you will get your function. Now give the plot command. Now change the value of n, that is f1x, f2x, f3x up to the f10x. You can also take more values. You can take up to the 30 value, or you can take the different values of the n. Then vary your x, that we are taking our x from minus 10 to 10, and then give the plot legend command. So from here you can see the graph of the function to be like this. So you can see the graph of each and every function, of each and every line of the function is converging on at one point, that is the 0. That is the 0. You can easily see the graph in the manipulate command, that when I give the command, that is the manipulate, and the manipulate, that I give the plot, and then sine nx plus n, then give the n plus 1. So always give the n plus 1 value in the brackets, in the circle brackets or curved brackets, and the angle must remember that it is the same, that is n x plus n. So this star sign is for the multiplication, and then the numerator is also 1. So what we are doing, we are adding the value of n, that is n plus 1, and then n plus 2. So I have taken the 3 sequence, and then x is varying from minus 10 to 10, and in the plot range I have also taken the same, that is minus 10 to 10, and then I am varying my value of n, that is 1 to 100. So you can see from the graph over here that when you vary your x towards the 100, you can see the graph become the straight on the x-axis. So you can see it is converging on the 0, and when you take the graph that is towards the 1, then you can see the graph is also converging on 0. So in this way you can see the graph of the function is convergent, that pointwise limit of the function would be 0. So in this way we will see the graph, and now come to the last question. So before proceed to this question, if you don't subscribe, please subscribe my channel, and thank you for watching the video, and if you are understanding, then please share it with your friends. Okay, so sixth question is what, that is the sine nx plus n upon n. Now the value of angle is changed and the function is lying between the r. So now I have taken the square bracket within the nx. Okay, now plus n is outside the square bracket. So plus n is what, it is not the angle. Now keep the n tends to infinity and vary your x varying from minus infinity to infinity. Now you can see the limit of the function changes. So the limit of the function will come out to be 1, and in the upper part, in the fifth question, you can see the limit of the function is 0. So in the conclusion, you can see the pointwise limit of the function is 1. The pointwise limit of the function is 1. Now define the question and see the graph. So that we define the question, that is f n subscript comma x subscript, and then equals to sin nx plus n. Then give the plot command to draw the graph. In the plot, vary your value of n, that is f1x, f2x, fn up to the f10x. So I have taken up to the 10. Then the x is varying from minus 10 to 10. You can take up to the any value because it is lying between minus infinity to infinity. Then give the plot legend expression, and then after that you can see the graph of the function to be like this. So in the graph you can say, it is converging on the 1, and if you not see the properly, then you can see in the manipulate command, that in the manipulate command we will draw the graph. So we will give the plot command, and then in the plot command we will define our three sequence, that is replace the n with the n plus 1 and n plus 2. So my first sequence is same as the question, then second sequence is n plus 1, then third sequence is the n plus 2. Okay, so in this way define your three sequence, then give the range of the x, that is minus 10 to 10, and the plot range minus 10 to 10, that is you are varying your x-axis, and with what we are manipulating, we are changing the value of n, and then we will see the graph. So after pressing the shift plus enter key, you will see the graph of the function to be like this. The graph of the function you will see like this, and when you will vary the value of x, then you can see it is converging on the 1. You can see on the y-axis, that is it is converging on the 1, and when you are shifting towards the value of n to be 1, then it is also, you can see it is converging on 1. Value of the pointwise limit of the given function is 1. So in this way we find the pointwise limit of the function. So now you have understood that how we draw the graph of the function, that is the limit of the sequence function, how we find, or how to draw the sequence of the function graph, or the pointwise convergence of the function of the graph. So I hope you understood the topic very well, and if you get any problem, you can contact me, or you can give the query in the comment section, and I will try to solve this question, your query as much as possible. So thank you for watching this video.